Okay, now we want to talk about distance in R2, distance in Rn, easy proofs, and angles in Rn. Should have written that down previously, but I didn't think of it. Okay, so distance in R2 just means, quick picture, got a vector, got another vector. If this is a vector u and this is the vector v, the distance is just the distance between the tips of the vectors, provided the initial points are the initial points coincide. And we can identify the distance with the length of the vector that goes from here to here, or the vector that goes from here to here. It's going to be the same, isn't it? Length is length. Length doesn't matter what direction you go in. So that's a really important idea. And we can do this with the Pythagorean theorem very simply, and we will. But then we also do this with the dot product. The reason we do this with the dot product, even though the Pythagorean theorem is really simpler in R2, by the time we get to R3, the Pythagorean theorem is not so simple, unless you accept the generalization that we get from the dot product. And of course, you should accept that. But you see, that then goes into R47 if you wish. I don't know why I keep picking on R47. It's, of course, one of my favorite vector spaces. But if you're in R47, you can use the Pythagorean theorem, that's fine. But we want to talk about it in terms of the dot product, because this then generalizes. To other kinds of what we call inner products. Okay? So, the dot product applies equally easily in R2 and Rn, so everything generalizes to Rn. Now we want to prove that it generalizes, but it turns out that these are easy proofs. Basically, just write down what you want to prove, in terms of general vectors. And we'll see what that means. And then angles in Rn. Now you know that in R2, if you want the angle between these vectors, you can easily find it, because you can easily find the three sides of this triangle. And then you can use the law of cosines and you get this angle. Okay, if you remember your basic plane trigonometry, that's easy. How do you do that if you got three vectors in Rn? Okay, well, turns out that it's kind of the same, but and then you go to R47, but it's easier to think about it in terms of the dot product in order to get our angles in Rn. And there's actually a simple formula. The angle between two vectors is the inverse cosine of u dot v divided by the length of u times the length of v. Dot product is really easy to calculate. You just make one vector a row, the other vector a column, and as we'll prove, it doesn't matter which is which. And then do the two magnitudes, which is basically just generalizing the Pythagorean theorem, but we're going to express it in terms of dot products so that we can generalize this to other, what we call inner products. Now we haven't gotten to inner products, we haven't defined any other inner products yet, but inner products are just ways of combining two vectors that follow the same rules that the dot product does. So we're going to want to look at the rules that govern dot products so that we know how to generalize this thing.